Welcome to our second video in our Unity series where we are setting up an enemy to chase us and attack us. We left off on the first video with the enemy being able to move. Now, there are a few bugs with this, like once we get within its stop radius, it doesn't turn to face us, and I think it will also pass through trees. But those are going to be kind of complex to fix, and we'll revisit those in a later video. So what we're going to work on in this video is we're going to try to get the enemy to fire a projectile at us, and then in the next video after that, we're going to actually get it to collide and register damage on the player. So let's get started with this. Probably the first thing that we'll want to do is head over to the projectiles and well, not the scripts, but rather the prefabs for the projectiles, and begin setting up the HoverBot's projectile. So mine, for some reason, the preview got grayed out, but it's a reddish bolt. So let's open up the prefab, and we're going to need to start configuring this thing to have all the components that we're going to need for usefulness, I guess. So first, I do want to shrink it down because I'm going to have it travel a little bit slower, so I don't need it to be a very long object. So I just dropped the Z to 1. Now, the things that we're going to want on this projectile, we're going to need a capsule collider. And the capsule collider is going to, we're going to need to reposition a little bit. It's going to be a trigger. So it's going to be like kind of a sensor zone. So switch the direction to Z-axis. Move the center of it up to, I want to say maybe like 0.5 on the Z. And then the radius, drop that to like 0.2. And if you feel like you want to shrink this a little bit smaller, you can. If you make this a smaller radius, the game becomes easier because it's harder for the enemy to actually hit you. And we do want to make it a trigger so that it's not considered a solid object. That's going to change how we code this. So collisions, instead of, I don't even know if we have any, I think we do have a few collisions. So collisions will now be using on trigger enter instead of on collision enter. That's what happens when you switch this, is it does change the event that gets triggered in the code. Also, it's no longer considered a solid object, so it doesn't like push things around. It doesn't, like, this collider isn't solid anymore. It's just you can walk through it now, whereas colliders usually do block movement. And we need rigid body. And then uncheck gravity because we don't want this to arc down. And as far as the interpolate and collision detection, I would probably switch it to interpolate and continuous because we want as much collision detection as we can, especially if the bolt ends up traveling fast. And it would be worth the computation to set it to these higher, more demanding settings because we definitely want accurate hit detection. There are no layer overrides. We're going to manually tell it to ignore the robot that shoots it so that it doesn't collide with its spawning parent, basically. All right, so that projectile is pretty much wrapped up there. And we can begin starting to work on the code in order to make this happen. So we're going to want to visit the enemy script first. And I want to begin preparing this for inheritance. So I want to actually program the attacking behaviors in a script unique to each enemy. But I want to keep this as the parent script where kind of the movement and a lot of main variables would reside here. And I suppose health will end up residing here as well. So let's kind of work our way through all these settings that we want. So I did actually think one thing that might make the gameplay a little bit more interesting is if once the enemy sees you, if its aggro radius becomes larger, so it's harder to get away, so you can't just dance on the edge of its aggro radius. So I would call this I call it a chase multiplier. And this is how much the aggro radius will grow by if it is currently chasing a player. And so that means we're going to need a variable to remember if we are chasing the player. So we need a Boolean called isAggro, and we'll set that to false. And we will use that to track if it is currently chasing somebody. A few other internal variables that we'll need. We're going to need a attack cooldown. And I'm making this protected so that the child inherits it and can see it. And to some extent, it might be worth making all of our private variables protected. So like this isAggro might want to be protected in the start position. That way, any children scripts have access to all of the variables that we have. And then we're going to need another one for stunned. And that's going to be whenever the monster or robot gets stunned, it won't be able to do anything. It won't be able to attack. It won't be able to move. And we'll use that actually. We'll stun it briefly after it attacks so that it kind of can't forever chase you and shoot you. So whenever it shoots, it kind of pauses for a second to give you a chance to either dodge or fire back or whatever we would want. So now we're going to make another collection of variables for settings for the attacks. Now these are general settings, and so these aren't specific to any individual enemy. So we're going to say public float ranged attack radius. The range at which this creature is going to want to attack us. Oh, well, we already have that, so let's just move that down there. We're going to want to have a melee attack radius, which may not get used, depends on the creature. And we'll want to set some cooldowns. Ranged attack cooldown, how many seconds in between attacks until the thing can attack again. And then we'll do the same for a melee attack cooldown. And that's all the new variables we need to add here. One thing I do want to do is have it so that during the update, after it does all the movement stuff, if it is stunned, so if stun timer is greater than 0, then agent.isStopped is true. So regardless of whatever it decided on, it gets stopped. But we don't want to say else agent.isStopped is false, because that could override some of its other stopping protocols that it used in decide movement. So we would just have to make sure that decide movement would re-enable agents regardless of whatever. So something to think about is that potentially because of this, we might want the first thing that we do is re-enable the movement, so that if we did stun it, at least it kind of starts with a clean slate every frame. So inside of this, there's not a whole lot to really change. I did want to change this part here, where if the player is within the aggro radius, I did want to implement that thing where it will chase the player a little bit more aggressively if it's seen it. So we'll set isAggro to true, and then we're going to use a inline if statement or a ternary if statement here. So we're going to take the aggro radius and multiply it by, if it is aggroed, the chase multiplier, otherwise 1. So the idea is that if is aggro is true, this expression will substitute into the value chase multiplier. So that's 1.5. So if aggro is true, then we multiply aggro radius by 1.5. If it was false, it will substitute into 1, and anything times 1 is itself, so nothing changes. So then other thing is when the player leaves the aggro radius, we need to make sure that we say is aggro equals false. So if the player gets away, the monster is no longer interested in chasing the player, and this bonus to the search radius gets taken away. Now that's actually kind of the end of the methods in here. I did want to add stuff to force the children to decide on how the attacks are going to work. So we're going to create a method called protected abstract void ranged attack, and we'll do another one for the melee attack. Protected abstract void melee attack. So protected is just so the children can see it, as opposed to public versus private. It's essentially a private method that external classes can't see, but children classes could see this method. Abstract is a polymorphism thing that basically forces the child classes. So when we start making unique scripts for each enemy, those scripts have to have a ranged attack method. So that way we can guarantee each monster or creature has its own unique way that it handles its ranged attack, how it makes its decisions for that. If that involves copy and paste, so be it. But either way, it guarantees the existence of that method. And so what we're going to do is, because we know those methods will exist, we're going to call them right here. Right after we determine our movement, we'll say melee attack and then ranged attack. So it kind of gives priority to the melee attack, this, all things being equal, this will be checked first, which could potentially apply the cooldown to attacking. So when this one gets checked, it would be an invalid, the attack would be under cooldown. So it'll only do really one of these, and it will prefer this. Then we want something to process these stunned variables. Now that I've got some kind of cooldowns going on, we want a method here called protected void process cooldowns. And all this is going to do is decrease stun state timer and the attack cooldown. So if stunned timer is greater than 0, then stunned timer minus equals time dot delta time, and same thing for the attack. If attack cooldown is greater than 0, then attack cooldown minus equals time dot delta time. So we're decreasing that. We could make it so that the child classes maybe expand upon this. If we want the child classes to override this, we can add the keyword virtual. Virtual, so in C#, you can't override a method without permission to override it. So by putting the keyword virtual, that allows this method to be overridden. We can still access it through a call to base, which is in Java is like a call to super. And let's do that to the update method as well. If we wanted to tweak this method, oops, wrong spot. So let's make this virtual, if I can spell virtual. So it's defaulting it to private. So we might have to override its visibility and switch it to protected so that the child class could see this update method and modify this update method. So then let's just call cooldowns. So process cooldowns. Now, this is going to kind of cause a pretty drastic change in our usage of this script. So since those new methods that we added are abstracts, we have to make the class abstract. So now this public class becomes a public abstract class. Now the downside, now that it is abstract, this class can no longer be used for our Unity objects. So when we go back to Unity, Unity is going to be mad at us because we have an abstract script here. Well, it's not going to load. It's interesting that it did though, but it changed it to a warning. So it said that the class is abstract, so the script class cannot be abstract. So we have to create another child class and replace this script with it. So inside of enemies, we're going to do that. We're going to create a new C# script. Just for organizational sake, I like to call it enemy_HoverBot. You could just call it HoverBot. And this is going to be the script that's unique to the HoverBot. Now, the nice thing about this is it does let us compartmentalize behaviors. So we can kind of keep all the movement and health stuff that's common to all enemies inside of the enemy class and only put the stuff that needs to be unique to this HoverBot inside of this HoverBot script. So let's change what it inherits from. So instead of inheriting from mono behavior, we're going to inherit from enemy now, which we still inherit from mono behavior because enemy inherits from mono behavior, therefore HoverBot inherits from mono behavior. But right now it's mad because I inherited from an abstract class, but I haven't implemented the methods, ranged attack and melee attack, that the abstract class wants us to have. So we can just let the compiler add these. And you can see that it automatically inserted these two methods for us. We don't need anything inside of melee attack. This robot's not going to have one, so we're just going to leave it blank. And so when it calls this method from enemy, when it calls melee attack, there's no code, so it's not going to do anything. Now we do want to write our stuff inside of ranged attack. And that's where we're going to kind of set that up. But let's make some variables that are unique to the HoverBot. So the first thing is stuff mostly related to our attacks. So we need a public game object, ranged projectile prefab. So that's the prefab that we need to attach. Ranged projectile spawn point, where we're going to spawn this attack from. Now, some of the actual gameplay related stuff. So let's give it a damage. So public float. Actually, if I recall, health is integers, so we'll do integers. So 10 damage. A projectile speed. We can go like 13 on that. That's still pretty quick, but that should be slow enough for the player to be able to dodge. And then a accuracy rating. How accurate this creature is. 0.8 will be pretty bad, and it will miss pretty often, but what I'm going to do to make that a little bit more interesting is add in a multiple attack accuracy bonus. And this is basically 2.5%. So the idea is that if the robot attacks you multiple times consecutively, every time it attacks you, it gains this bonus to its accuracy. So it becomes increasingly more accurate with each shot. So if you don't deal with it, it will eventually reach 100% accuracy, which it'll be dead on shots on the player. So some audio variables. Public audio source. We might have multiple audio sources, so we should specify a ranged attack audio source. And we're making it public so we can manually pick which one it's going to be. And then an audio clip, ranged attack audio clip. And then as far as let's actually put this up here. A collider array of attack colliders to ignore. So we would put all of the colliders on this HoverBot that we wish the engine to ignore collision with, so the robot doesn't shoot itself, basically. Because otherwise that would happen. When it first spawns this projectile will be touching the robot, and it would count as hitting the robot. So we need to tell it to ignore the robot's collider. And we'll put a private variable here for the current ranged accuracy bonus. How much of a bonus has it accumulated so far? Now, you could put tooltips on all of these, and I might do that in between videos, but I'm not going to take the time to do that because this video is already pretty code heavy. So we could hit save on this. And at this point, this script is usable again. And so we'll verify that and test that before we continue, before we write this ranged attack. So coming back to here, the HoverBot, let's go edit the prefab for the HoverBot. Now the HoverBot doesn't even have the script on here. So it's kind of interesting. I guess we should see what we changed with this. I think the only override was actually putting the script on there. Yeah. So we can just hit revert all, and we can go edit the prefab parent here and attach our script to it. Now we can no longer attach the enemy script. If I try to, it warns me that the script is abstract. So I have to attach the HoverBot script to it now. But you'll notice it actually still has all the variables from the enemy. So all of the settings that we had before are still there, but we also now have the stuff that's unique to the HoverBot. And so that's how we're going to set up our enemies, is we'll have a parent enemy class or script that handles common stuff like health, maybe a little pop-up health bar, movement, and then all the stuff unique to that enemy will be in the child script. All right, so we need to attach well, we can attach this later. Let's play test and make sure it works. So with all those changes, really nothing happened. Like, it still kind of chases us. We might need to make that stopping distance a little bit further away. So let's actually do that on the prefab here. So the stop distance, let's make that like 10, and we'll make ranged attack 12 and aggro radius 14. And I do want to edit that script real fast. So there was I was printing out the distance to the player here. And I do want to take that out so it's not filling up our debug log. Okay, so with those changes, the HoverBot it still works. And so what we want to do now is write the code for it to attack the player. So inside of ranged attack, this is going to get kind of very similar to what was going on inside of the movement script. First up is we need to track the player. So we could take this first part of the movement script, calculate distance to player, and take that for our attack script. So I'm going to copy this and go back to the HoverBot, and I'm going to paste it. So essentially what this is doing is we're getting the distance to the player, we're figuring out where the player is, although I do want to make one tweak to that, because the player positions actually, for whatever reason, if we look at it, the player position is the head of the player. So, like when I go look at the player object here, you can see that if I switch all this to even global, the position refers to like this head of the player. And so if we leave that to be, then it's going, the robot's going to always be targeting at the top of the player. I want it to shoot kind of center of mass. So I'm going to do a quick tweak to the player's position, and I'm going to subtract a little bit from the Y value. So, and I'll put a little comment here. And we're adjusting that because for whatever reason, the position seems to be the head of the player. This will make it more kind of the chest or the center of mass. So when we start calculating the attack vector, we won't be like, because if you're shooting at the top of the player, you might miss if you aim up a little bit. Okay, so now time to actually code the logic for attacking. So we're going to check to see if the player's in range and attack. So if distance to player is less than or equal to ranged attack radius, and I believe that was a variable from the parents. So ranged attack radius is actually coming from here. So we have access to all of these variables inside of this child class. So we have the new variables, but in addition to all of our old stuff as well. So if we're in range, then we want to check to make sure that we're not under cooldown or we're not stunned. So if attack cooldown is less than or equal to 0, and stunned timer is less than or equal to 0. So only attack the player if we're not stunned. So this gets a little bit vectory. So first thing we're going to do is calculate the direction to the player and then normalize it. So vector 3, direction to player is the player position, which is that thing we calculated before, minus the HoverBot's current position, and then dot normalize turns that into a unit vector so that it won't be disproportionately large when we add in the randomization to it. So when we add like kind of the shot inaccuracy, if this vector was super large, that would overpower the inaccuracy. So we're going to calculate this as a vector initially. So first, we need to come up with the inaccuracy, which would just be 1.0 minus the ranged accuracy plus the ranged accuracy bonus. Now we want to generate the random vector. So we'll call this deviation. If I can spell that right. So deviation. Now, here's kind of the initial issue. I'm just going to generate a random vector inside the unit sphere. Maybe I should do on unit sphere, but that might be a little too extreme. So I'm just going to go with inside unit sphere. And yeah, well. So it works. Multiplied by random.range from 0 to inaccuracy. So the magnitude of that is going to be multiplied by a random number from 0, which would mean it would be a perfect shot, to inaccuracy, which means it will be as wild as this shot is, times a little bit of a multiplier. We'll go with like 4.0. This is something you can tweak. This just makes more deviation more extreme. So then we add the vectors. So we take the direction to player plus the deviation, and then that creates our new randomized vector. Then we'll renormalize it. So that it's back to being a unit vector after we added those two things together. And then we go through the process of spawning the projectile normally. All of this code was basically just to add random inaccuracy. So we've done this a billion times. Game object projectile equals instantiate ranged projectile prefab at the ranged projectile spawn point. And then the rotation, we want the projectile to face the direction we're about to send it in. So we would say quaternion dot look rotation, and that will convert that vector 3 into a rotation. Oh, it already finished it for me. So we want it to go to randomized direction. And that needs dot position. So now that it's spawned, we want to grab the rigid body on the projectile, which it should have. So rigid body, projectile, rigid body, equals projectile.getComponent rigid body. Now this is actually different than just running that initialize method that we had on our projectile script. It's just another way to do the same thing. So projectile rigid body dot velocity equals that randomized direction times the ranged projectile speed. So that gives it its direction and speed. Now we want to assign all those variables for damage and stuff. So So that would be done with projectile.getComponent iProjectile, which we need to put that on there. It doesn't have it yet. Initialize. It is, the owner is enemy, so now we know who owns this, and then range projectile speed, which we're just manually setting here, and then the damage. Kind of a long series of things here. Still more to go. Then we want to apply the cooldown to the enemy. And I like to stun it. So I'll say attack cooldown equals ranged attack cooldown. And then the stunned timer will be half of that. So it still ticks down, the cooldown still ticks while stunned. So what this effectively does is for half of the duration of the cooldown, the enemy can't move. So that way when it shoots, it stops moving for a little bit to give you a chance to either get away from it or fire back. Now, this one's important. We want to ignore the collision between the projectile and the enemy's collider. Otherwise, the moment this projectile spawns, it will immediately just disappear. So we want to get the projectile's collider. And then loop through all of the colliders in the list. And this is so that if you have multiple colliders with an enemy, maybe you want to have a body and a head to have different colliders for registering damage. Maybe it has different colliders for its legs. It's possible that you might have multiple colliders that you'll want to ignore. So that's why we're going to use a loop. So for each collider, and then we'll just call physics.ignore collision between the projectiles collider and that's spawn collider. So if there's only one, we just ignore collision with the one. Otherwise, we would loop through all of the colliders to ignore. Because ignore collision doesn't have an overload where you can specify this as an array or anything. So we just got to manually do that. Then give the enemy a bonus to accuracy. So ranged accuracy bonus plus equals the multiple attack accuracy bonus. And then we want to make sure we cap this so it doesn't go over 100. I believe we could use probably clamp. Well, I don't know. I trust min more. I mean, I haven't tested that. So we're going to do ranged accuracy bonus, which is what we currently have, or 1 minus the ranged accuracy. So basically, if it has 80% accuracy, this would be 0.2, so that we never make this greater than 0.2. So it's the minimum of the current bonus or 0.2. So if the current bonus ever exceeds 0.2, it will never it won't go over that. So our accuracy maxes at 100%. And then play the sound effect. So if the ranged audio source is not null, then we will play the audio clip. Whoops. So we'll use the play one-shot command. So if we have assigned a sound effect and the audio source is correctly linked, then play the sound effect. And that is a very long method. So we'll save that and we'll test this. This should produce a robot that shoots at us. We still need to go through and make sure that the player can get hit by that, but we'll do that in the next video. So let's rig up the robot with all the things that it needs. So we kind of go through here. We need to give it the projectile. Well, we still need to make that script for this thing, which is a pretty quick thing to do. So let's go attach that. So we're looking to put the projectile to that. Now, the spawn point, I know that there is this like gun route and stuff, but it's facing the wrong way. Like if I turn off gizmos, the blue axis, which is the forward axis, is facing into the robot. So I probably need to like rotate this. I don't know why it's backwards, so we could just change that Y to positive or just to 0. And so that way, you know, that's going to be where we spawn our thing from. Here's an audio source that's kind of built into the thing that we can use. And this would be a good audio source. So weapon eye lasers will be where we attach the audio source to. So we will take weapon eye lasers for the audio source. And then we need to range attack spawn point. You know, we do gun muzzle. And we just have to attach the audio. So there is audio in here. So for the HoverBot attack, which is the second one there, we can go and place this right there. So it would work, except for we don't have a ranged script for the projectile. So we don't get to see this in action. So let's go put that together real fast so that we can at least see the robot shooting at us, and then we can move on from there. So in projectiles, let's just make a new C# script called projectile underscore enemy. And we'll just make this kind of a generic one that we can use for multiple enemies projectiles. So we want to put comma to inherit from the I projectile, but I think the quickest way to get this thing set up is just to take the player blaster projectile and copy this and paste this into my enemy projectile. So I'm going to paste all this. Now, I don't have a particle effect, so I'm just going to comment this out for now. And if you wanted to add one, you could just construct one. Then the rest of this, so because I don't have my particle effect, I'm just going to take that out again because I don't have my, I'm not going to set one up real quick. And then because I was handling the speed inside of the, when I spawned it, I'm going to just take this out. And right now we have an on trigger enter, it triggers impact. We will eventually come back to modify this to make it so it does something different if it hits a player. but for now it's fine. So we're going to hit save on this. And then attach this to our HoverBot projectile prefab. So we've just got to find it in prefabs, projectile, and then my HoverBot prefab. We will take this script, projectile enemy, and then attach it to here. And now there's nothing we have to do. It should just automatically do its thing. There's no sparks or anything. It'll just disappear when it hits something. That's fine. So now we should be able to see the enemy attack us. We've done everything we need to do there. Now we won't get hit by it. I mean, it'll just disappear instantly when it hits us. Oh, we forgot to rig the colliders. That's what will happen when you don't set up the collisions to ignore. You can see that the laser spawns, but it instantly is getting destroyed because it's colliding with the robot. So that is handled right here. Attack colliders to ignore. Set that to 1 because it only has 1 collider. And we want hitbox. Hitbox actually has a sphere collider, and that's actually what the laser is hitting and destroying itself on. So if we put hitbox into this list, now it will appropriately ignore that collider. If this creature had more hitboxes, we would just hit plus and just add all those different hitboxes to it. And so here we go. It shoots at us. Now it's going to be slightly inaccurate, and then as we stand here, it will get more and more accurate till it reaches 100% accuracy, where it will continuously shoot us in the same spot without missing. And it's getting closer there because it's 2.5 each time, so it should, yeah, I think it's reached about 100% now. So the longer it's around, the more accuracy. Now, we did not set that to decay. So if I run away from it and then come back to it, we never set that to decay. So it's going to shoot us with perfect accuracy because it's keeping that same variable. So that's going to be the last thing we do here. Is to make it so that that accuracy will decay over time. Now we want to call update. So we want to utilize the parent's version of update. So we'll say protected, override, void update. And you can see it like auto called base.update. So this is like a call to super in Java. It's going to run all the stuff that was inside of enemies update, so all this will happen, and then all we've got to do is anything extra here. So if attack cooldown is less than or equal to 0, so if the enemy hasn't been attacking, we want to start lowering the accuracy bonus. So we'll say ranged attack bonus minus equals multiple attack accuracy bonus times time.delta time. So essentially what that will do is every second it will lose every 1 second it loses that 25%. So every attack it got that, but every second it's going to lose it. And then make sure it doesn't ever go negative. So ranged accuracy bonus equals mathf.max of the current bonus or 0. So if this is ever like negative, it will choose 0 because 0 is larger of the two. And then that will cause it to reset after a while. It'll go back to being inaccurate. And so that's going to wrap up this video. In the next video, we're going to get the lasers to hit the player, update our health, and make the screen flash red. And then in the video after that, we will be able to finally return fire and begin to damage this enemy. So thank you for watching, and I'll see you in the next video where we can actually get hit by these lasers.